I want to multiply the complex numbers z and w together. Okay, that's what zw is representing. All right, so this is not necessarily a difficult task. I could do this the long way, which maybe this is not the long way for this particular problem, but I could actually just multiply them out by distributing. And so that times that, this, and then combine like terms. Okay, but that's not what we want to practice in this section. Okay, what we want to do is use what we know about trig notation for complex numbers to make this process easier. Okay, so the complicated part is writing z and writing w in trig notation. Okay, that's what we're going to focus on right now. So that's going to take a little bit of time, but once we have it like that, the rest of these operations are actually really simple. Okay, so let's start off by trying to rewrite z as a write z, the complex number, in trig notation. I'm going to write out our formulas really quick off to the side here. A is equal to the magnitude times cosine. B is equal to the magnitude times sine. Okay, and then of course to find the magnitude itself, we need the square root of a squared plus b squared. Okay. Now, the magnitude of z, let's do that first. Is going to come from a squared and b squared. Okay, well, a is negative 6, the square root of 3, and b is 6. Okay, so negative 6, the square root of 3. Well, the 6 squared is 36. The square root of 3 squared is 3. 6 squared is 36. Thirty-six times 3 is 108. Plus 36. That's 144. And the square root of 144 is 12. Okay, so the magnitude of z is 12. Okay, we would say that z is in the second quadrant because it's a negative and a positive. Okay, remember, negative and a positive occurs in the second quadrant. Okay, we're going to use that to find theta for z. Okay, so a equals the magnitude of z times cosine theta. Well, a is negative 6, the square root of 3. And the magnitude of z is 12 cosine theta. If I divide both sides by 12, then what happens here is 12 cancels, and negative 6 over 12 is negative 1/2. So that actually makes this negative square root of 3 over 2 equals cosine theta. Now in quadrant 2, cosine equals negative square root of 3 over 2 at 5 pi over 6. So there's my theta. So finally, I can write out z, and I'll put it in a different color so I can spot it easily, is 12 cosine I sine of 5 pi over 6. Okay, so I'm going to hang on to that. Now I need to do the same thing with w. Okay, so the magnitude of w, the formula is going to be the same. The square root of a in this case is negative 3, the square root of 2 squared, plus b is positive square root of 3, or 3 times the square root of 2. So I'm just going to square those. Negative 3 squared is 9. The square root of 2 squared is 2. 9 and 2. That's going to be 18 plus 18, which is the square root of 36. So the magnitude of W is 6. Okay, again, because we have a negative and a positive, we're going to say that this is quadrant 2 that is represented. So I need to find an angle that is in quadrant 2. Okay, so let's use the cosine one again. So A is negative 3 the square root of 2 equals magnitude of W, which is 6, cosine of theta, right? I'm using this formula here, except a W instead of a Z. If I divide both sides by 6, sixes cancel. I'm left with negative, this becomes 1/2. So negative the square root of 2 over 2 is equal to cosine theta. Now, in quadrant 2, cosine is negative square root of 2 over 2 at 3 pi over 4. Okay, good. So now W, the complex number W, is 6 cosine I sine of 3 pi over 4. Okay, we haven't even gotten to the problem yet, right? We rewrote these. I promise we'll use these multiple times, okay? Aside from this problem. All right, so we have Z and we have W. Now let's actually answer the question, what is Z times W? Okay, and here we're going to use the rule for multiplying complex numbers in trig notation. And you multiply the 12 and the 6 together, the two magnitudes. Maybe I'll write out the formula first so you can see it. So you multiply Z and W, the magnitudes, and you add the angles. There I go writing the wrong thing here. So the angle for W plus the angle for, or the angle for Z and the angle for W. Okay, that's the formula. It's simple multiplication and addition at this point. All right, so 12 times 6 cosine I sine 5 pi over 6 plus 3 pi over 4. Let's carry out this really quick. 12 times 6 is 72. Cosine I sine. Now to add 5 pi over 6 and 3 pi over 4, I'm going to find a common denominator here. Pi over 4. 12 would be a denominator, so I'm going to multiply the first one by 2 over 2. The second one I'll multiply by 3 over 3. And add those together to get 19 pi over 12. So 19 pi over 12. All right, so notice how easy it was to multiply them together once I had them written in trig notation. Okay, there we go.